Hello experimenters. I'm making a quick video here about these pancake motors, these high pole count pancake motors that are used in mainly in washing machines and such as Samsung. This is a Samsung, out of a Samsung front loader machine. They're also used in the top loaders and LGs, and I think even some dishwashers are using these direct drive low speed motors now. This one's a 48 pole motor intended for low speed operation. It's rated at 1000 RPM maximum. It's about 12 inches in diameter, and I have it mounted on the part of the transmission that comes with the washing machine. It's kind of stripped down to the minimum that you can get by with here. With the stator under here, it has a 36 poles on the stator, and inside there's a planetary transmission inside the metal housing at the bottom, but it's not being used as a transmission. It's just being used to hold the rotor in the right place. So I want to show three uses of this. One of the first things I'm going to do is show it running on a variable frequency drive. This is a 110 volt 0.75 kilowatt 1 horsepower variable frequency drive unit that I bought on Amazon. They're available from a lot of other places too. Most of the parameters for this control unit, this variable frequency drive, are okay as they come from the factory. One of the settings is a motor frequency of 50 Hertz, which is satisfactory for this motor. But the one thing that definitely needs to be changed is called parameter 10, and that needs to be set to something like, it can be set up to the full 400 Hertz of the drive unit. With a 48 pole motor, it takes 400 Hertz to bring it up to its full rated speed of 1000 RPM. And when we turn on the drive, start increasing the frequency here, we can see we can run the motor at a fairly low speed, bring it up to, in this case I'm going to bring it up to 500 RPM. Slow it back down to about 250. Let's give it a reverse. Anyway, the motor is quite usable as it's intended, as either a low speed or up to 1000 RPM. It runs quite nicely on the variable frequency controller. Another use for this motor might be as a low speed generator for something like a water wheel or maybe some wind power. You can see, even at just turning it with my hand, I'm pretty easily able to light this 24 volt bulb. So it doesn't take much speed to generate good voltage with this, using this motor that way. I don't have a lot of other measurements on this, so I can't say what it would actually do with a good drive, but it looks promising for as a generator, low-speed generator. I should have been saying alternator instead of generator when I was talking about using this to generate power. It's actually going to produce an AC voltage, and it'll take something like a diode, the diode bridge out of a car alternator to change it to DC. Now the third application I've got is using it as a low voltage stepping motor. I've got a switch set up here which connects the different phases to the negative side of a low voltage power supply, and I have made a modification to the motor by adding a wire to the center tap of the 3 windings, which is very easy to do because there's a large clip that clips the 3 wires together on the stator. And right now we're going to be running at 4 volts, so this is a very low power, no danger, no electrical hazards kind of an application. And as you can see, I can easily control the position of the motor, and it has really good torque even at just 4 volts. It's difficult for me to move it by hand to get it out of sync, and it can be driven at even higher power levels up to about 18 volts is about the highest you'd want to run. 12 is a good operating level. At 12 volts, it will be running just about 2 amps of current through the coils, and you can see it's quite violent on the motion when you touch this point with something that isn't tied down to the rotor itself. Of course, you can also take power off of the shaft on the other end. You could belt or chain drive something with this. It's there we go. This switch just grounds the 3-phase connections, or connects them to the negative side of the power supply one at a time. Could easily be done with MOSFET or regular or bipolar transistors driven from a computer to do the rotation. I don't know what the maximum speed would be, but this would be better for a low speed where you're just positioning something like a sign, or some kind of display maybe. If there's anything you wanted to drive remotely, you could easily do a fairly long cable to this thing. Anyway, that's kind of some ideas about how to use these pancake motors. They're getting to be quite available, as I see a lot of the machines are starting to show up on the curb, the washing machines with these motors. And so they're probably available free if you want to stop and take one out. And just hope this has been useful information for you. I forgot to mention that the steps, to the way I'm driving it, are 5 degrees each. With the driving from the center tap, you could get down to, should be able to get 2.5 degree steps by driving with bipolar drivers, but they would be much more difficult to implement. The reason for the 5 degrees, it's a 48 pole motor, but since we're only driving the magnets in one direction, it's actually 24 poles that are being used, and those will be 15 degrees apart. The rotor has 36 poles, which are 10 degrees apart. So what you get is the difference between the two, the 10 and the 15, which results in the 5-degree steps.